Hello Year 5 and welcome to our next maths lesson on fractions. So today we are practicing identifying equivalent fractions, so equal fractions. Once again, equal, really important word, so it's why it's word of the day still. Warm-up activity is the countdown activity, so you've got your target number, 981, and you've got your numbers that you can use once, so 25, 9, 3, 1, 5 and 4. So how can you use those and the 4 operations to reach your target, or as close to it as possible? Also, don't forget to convert your Roman numerals into Arabic numbers, so into normal numbers that we use. So pause the video and have a go at those 2 tasks. Okay, so let's very quickly go through the Roman numerals. So we have 3 i's. I is worth 3, so that 1 times 3 is 3. I is worth 1. 1 times 3 is 3. 2 i's is 2 lots of 1, which is 2, so the third of the second. 2 m's, m is worth 1,000, so 2,000. I'm just going to write these down because it's a long number. So write them together. 2 x's, x is worth 10, 2 times 10 is 20. 1 I is worth 1, so 1, so 2021. So the third of the second, 2021, 3rd of February 2021. Let's have a look at how I approach this and how I got the answer. One of the methods you can use to get there. Okay, so to get there, once again, I'll tick them off as I use them. We've got 3 plus 1, which is 4. Let's do that properly. 25 times 4. 4 we just created, so I don't have to cross this one. 25 times 4 is 100. 100, which I made, plus 9 is 109. 5 plus 4, so we've still got the 4 here, 5 plus 4 is 9, and then 109 multiplied by 9 is 981. So that's one method you can use to get there. There are other methods, so if you got it in another method, that is fine. So well done if you got there, well done for trying if you just got close. Okay. So we have 3 questions here. I've noticed that this one is covered up, so I'll come up with a question and I'll answer that. So circle the non-unit fractions. This one I'm going to say what fraction is shaded red, and this one is what fraction of the bar is shaded blue. So pause the video and complete those questions. So number 1, it says circle the non-unit fractions. Remember that unit fractions are where fractions that have the number 1 as their numerator. Numerator's number on top. Oh, there we go. They're saying it's orange. I thought that was red. Anyway, so the ones without number 1 on top are those 3. So 1/7 and 1/9, they are unit fractions. And these are non-unit fractions because they don't have 1 as their numerator. The next one says what fraction of the bar is shaded orange. I said red, so it's still going to be the same. So we've got how many parts in total? 1, 2, 3, 4, 5. Our denominator will be 5, and 2 parts out of 5 are shaded. So the fraction is 2/5. The next one is what fraction of the bar is shaded blue. So you count the total number of parts for the number on the bottom, the denominator, and how many are shaded for the numerator. So we get 4 parts out of 10 are shaded blue. Okay, we're going to move on to our equivalent fractions. Equivalent means the same value or amount. So we're just going to have a look at a couple of things here. So 2 1 pennies is equivalent to a 2p. So 2 individual pennies is equivalent or the same in value as 2p. We'll look at some place value here. So here we have counters and they're worth 100th each. We have 10 hundredths. 10 hundredths, remember the maximum digit you have a place value column is 9, so we're going to have to exchange. So 10 hundredths is the same as 1/10. Here is a strip of paper. I cut it into 2 equal pieces. Here is a strip of paper. I cut it into 4 equal pieces. What do you notice? Pause the video. What do you notice? So at the top, split into half, so that's a half together to make a whole. The second bit of paper is split into quarters. So we have 1, 2, 3 quarters, 4 quarters make a whole. And if we shade in 1/2 and we shade in 2 quarters, you'll see that they take up the same amount of the whole. So 1/2 is equivalent to 2 quarters. And here is where we can see if something is equivalent to a half. If you times the numerator by 2 and it equals your denominator, it's equal to a half. Times the numerator by 2 and the number you get is equal to the denominator, it's a half. So for example, let's just look at this one. So 4/8. If I times that 4 by 2 and it equals 8, then that is a half. 4 times 2 is 8, so that is equivalent to a half. I'm just going to rub that out because I think something might be coming in to go over that. And likewise, the inverse of that, if you divide your denominator and you get your numerator, it's equivalent to a half. So 2 divided by 2 is 1, yeah. 4 divided by 2 is 2, yeah. So that's just a way of showing you equivalence to halves. Okay, so we have a number line with quarters on. And here we've divided a whole into 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So here 1/4 is equivalent to 2/8. 2/8 is equivalent or equal to 1/4. Here we have split it up to 20ths. And 5 of those have been shaded, and as you can see from the amount of space it takes up, that 5/20ths is equivalent to 2/8, which is equivalent to 1/4. I wonder if you've noticed any patterns in the numbers. Like how would you get from the numerator to the denominator? How would you get from the denominator to the numerator? I wonder if you've noticed any patterns. So we have 3/12, another equivalent fraction, because if you shade in 3 parts out of 12, and you compare them, it takes up the same amount of space. So 1/4 is equivalent or equal to 2/8, 5/20ths, and 3/12. Okay, so now we're thinking about those numbers and what calculations we have to make to get between them. So we need to think now, how do I get from 4 to 8? What do I do with a 4 to get to 8? 4 times 2 is 8. And remember, with fractions, whatever you do to the top, you have to do to the bottom. Whatever you do to the bottom, you have to do to the top. So if I've times that by 2, I have to times that by 2. 1 times 2 is 2. Okay, let's see how we can get from the next one. Getting from 2 to 3, that's pretty hard. What else can we do? We can get from 1 to 3. So if we want to know what is equivalent to 3 parts of what is equivalent to a quarter, so we go from 1 to 3. So 1 times 3 is 3. Whatever we do to the top, we do to the bottom. 1 times 3 is 3. 4 times 3 is 12. Whatever we do to the top, we do to the bottom. Here, getting from 12 to 20, can't do that. Let's go back to our quarter. How do you get from 4 to 20? 4 times 5 is 20. Whatever you do to the bottom, you do to the top. So 1 times 5 is 5. Okay, and then if we're looking at 16ths, how do we get from 1 to 4? We multiply it by 4. 1 times 4 is 4. Whatever you do to the top, you do to the bottom. 4 times 4 is 16. So that's how we work out equivalence. We can also get to our 40ths. Let's rub all these out. So how do you think? What do you do to that number to get to there? Remember, whatever you do to the bottom, you do to the top. Whatever you do to the top, you do to the bottom. Okay, let's look at the 1 to 10. 1 times 10 is 10. Is 4 times 10 40? Yes, it is. So once again, we can work out another equivalent fraction. So what do you notice? just going to look through this again. 1 times 4 is 4. 40 divided by 4 is 10. Times it by 2 there. Times it by 3 there. Times it by 5 there. Times it by 10 there. So it's just what we've gone through, just with some slightly different arrows. Okay, so with this one, how do you get from 3/4 to 12 something? So we've got the equivalent fraction. So let's have a look at this. To get from 3 to 12, you multiply 3 by 4. Whatever you do to the top, you do to the bottom. So if we've times the top by 4, you have to times the bottom by 4. And 4 times 4 is 16. So 3/4 is equivalent to 12/16. Let's just have a look at that visually. So we've got 3/4 there. If we divide that into 16ths, we have 12/16ths, and you can see they take up the same amount of space as 3/4, and that is why 3/4 is equivalent to 12/16ths, and 12/16ths is equal to or equivalent to 3/4. They are of the same value. Okay, so have a pause and think, how can you work out what these missing numbers are? So pause the video. How can you work out what these missing numbers are? Remembering what you do to the top, you have to do to the bottom. So pause the video and have a go at those. Okay, I'm just going to write about my lines because I'm pretty sure something's going to come over them now. Okay, so to get from 4 to 12, you have to multiply by 3. Whatever you do to the bottom, you do to the top. I've times my bottom by 3, therefore the top has to be multiplied by 3. So 3 times 3 is 9. So 3/4 is equal to or equivalent to 9/12. If you look at the bottom, we have to work backwards here. So 15 divided by 3 is 5. If we divide the bottom, the denominator by 3, we have to divide the top or the numerator by 3. So how many 3's in 9? 3 times what is 9? 3 times 3 is 9. So 3/5 is equal to or equivalent to 9/15, and 9/15 is equivalent to or equal to 3/5. So once again, a fantastic opportunity to pause the video and have a go at the questions 1 to 4. If not, if you want to listen to all of it, then obviously you are more than welcome to do that. And just remember, if you do get stuck, if you mark your work and you figure out you got something wrong, just see if there's anywhere in the video you can look at to help you correct your mistakes. Okay, so here, Tiny the Turtle is back causing havoc, and he says that 2/3 is equal to 8/9. And the way that he's done it, because he looked at the denominator and thought, how do I get from 3 to 9? And he said, oh, all I know, I have to do add 6. So he's added 6 to both the numerator and the denominator. He is stating that 2/3 is the same as 8/9. So pause, have a think. Do you think he is correct? So he's added 6 to both sides. Okay, let me just rub those out. Okay, here's 2/3. If we split those 2/3 into 9ths, we have 6/9. That's not 8/9. So you have to times or divide to move between the denominators and numerators. So here, the denominator has been multiplied by 3 to get it into 9. So we have to multiply our numerator by 3. 2 times 3 is not 8. 2 times 3 is 6. So 2/3 is equal to or equivalent to 6/9. They are of the same value. Okay, if we have a look at this question here, how do you think you can answer that? How can you move from one fraction to the other? Are some methods easier than others? Have a pause, have a think about that. Okay, so we've got 12/15 is equal to 40 somethings, which is equal to something fifths. So how do you get from 12 to 40? You can't. You cannot multiply 12 to get to 40 using whole numbers, which is what we have to use. So let's look at this. How do you get from 15 to 5? You divide it by 3. We can divide that by 3. 15 divided by 3 is 5. Whatever you do to the bottom, you do to the top. So I've divided the denominator by 3, therefore I have to divide the numerator by 3. 12 divided by 3 is 4, because 4 times 3 is 12. Okay, now we've done that one. How do you think we could get to 40 somethings? We don't have to use the 12s. We can use the 4s. So we know this one is equal to or equivalent to this one. So let's work from this one as that is possible. So we do 4 times 10 is 40. Whatever you do to the top, you do to the bottom. My numerator has been multiplied by 10. So I have to multiply my denominator by 10. And 5 times 10 is 50. So we have 12 fifteenths is equal to or equivalent to 40 fiftieths, which is equal to or equivalent to 4 fifths. Okay, so your work has been assigned to you. Make sure you work through those worksheets, maybe having a look back at the video. If you get stuck, mark your work, see how you've done. If you have any questions about your work or if you get confused, let us know on Teams or Tapestry, and then you can come to one of the live feedback sessions and ask your questions, and we will go through that either there, or we might be able to sort out another way of helping you with your work. Thank you very much for all of your hard work again, and thank you for listening to your Wednesday maths lesson. Bye.